Welcome back. So let's talk about the let's talk about the galvanic cell. What is galvanic cell? Galvanic cell is basically just briefly what I said in the last lecture. You have a solution where you have some chemical, okay, and you have some chemical and they undergo some change, okay, and that change actually produces the electricity. Okay, shows the deflection in the ammeter. Okay, so this is known as the galvanic cell. Now let's say what happens. Okay, this is a very interesting thing. What happens? Let's say let's say talk about this reaction particularly. This is a very standard reaction. Okay, so what is this? This is a zinc plus copper 2 plus solution, and then what is generating copper solid and then zinc plus 2 aqueous solution. Okay, so this is a standard oxidation reduction, or I would say redox reaction. Okay, now let's talk about the half cell reaction. So what is the half cell reaction here? The zinc solid is converting to the Zn plus 2, right? This is one, and the copper plus 2 is converting to copper solid. Now, zinc is going from Zn to Zn plus 2. That means he is releasing 2 electrons, right? And copper 2 is going to copper. That means it is taking 2 electrons, right? So this is a half cell reaction. That means zinc is going from zinc to Zn plus 2, and this process is known as, this is what? This is his oxidation. This is oxidation, and this process copper 2 is going to copper, that means is accepting electron. It is known as reduction. Okay, so this is oxidation and this is reduction. Okay, now this here, this half cell, as I said, this is a half cell. These are the half cell reaction. So this is known as also one electrode reaction, and this is also an electrode reaction. Now let's say here what is happening? See, zinc is oxidized to Zn plus 2, and copper is reduced to copper solid. Okay, now here zinc is an reducing agent and the copper plus 2 is an oxidizing agent. Let's write here. So zinc is basically a reducing agent, okay, and copper plus 2 is basically here is an oxidizing agent. Okay. Acha. So now let's say if I say that here the oxidation half, which is the oxidation half, this oxidation half, okay, they are producing the positive ions, okay, by releasing the electrons, the oxidation half is producing the positive ions, okay, and this ion, this, since this is positive, okay, positive ion, so we can term this electrode as anode, this electrode as anode, and this copper electrode we term as cathode, right? Copper electrode we term as cathode. Excuse me. Okay, this copper electrode we term as cathode. Now, so if I say that what is the reaction in happens in anode? So this is the anode reaction, and what reaction happens in cathode? So this is the cathode reaction. You can write it. So whenever an oxidation takes place in particular electrode, that electrode is anode, and reduction takes place, that electrode is a cathode electrode. Okay, just keep this in mind. This is the convention. Okay, acha. Now anode. Okay. So what will happen here? The electron flow is where will be come from? The electron will flow from anode to cathode, right? The electron flow will come from anode to cathode. The electron flow. The electron flow will come from anode to cathode. Okay. Now, so if I term this, so if I can, so I can say this is a cell reaction, overall a cell reaction, right? Right? This is overall a cell reaction. And what is happening? Zinc is going to Zn+2 and copper 2 is going to copper. So how will I represent this cell reaction? Representation. That's very important. Representation. Okay. What is the representation? So zinc is going to Zn+2 and copper 2 copper. Okay. So this is a representation of the cell. Okay. Okay. Now this is the representation. So what is the interesting thing about this galvanic cell? Okay. So interesting thing, as I discussed, is the oxidation is taking place in anode. Okay. And the reduction is taking place in the cathode, and the electron flow is going from anode to cathode. Okay. Now, so electron flow is there. Reaction is also happening. And what about the electricity? Right? Here, each of the electrodes each of the electrodes has a potential or a charge. Okay, and that charge is known as the electrode potential. Okay, acha. And that electrode potential, if that electrode potential in that electrode potential oxidation is taking place, electrode, then that is known as oxidation potential. And if in that electrode reduction is taking place, then that will be known as reduction potential. Okay, let me tell you. Let's say in general, okay, if I talk about in general, let's say you have a M element, okay, and that element is undergoing some process, okay, and it is forming Mn plus n electron, right? Now what is this process? This process is this oxidation. So this process will have a particular E potential associated with it. Okay, and this is since this electrode, if I think about this as the electrode and this will be in the solution, this is in the solution and this is the electrode. So there will be an equilibrium between the electrode and the solution by releasing the n electrons, and that is known as the electrode potential of this reaction. And this reaction is an oxidation reaction. Okay, so that this will be electrode oxidation. Okay, that means this is oxidation. This is oxidation potential. This is oxidation potential, and this one. And if I think that Mn plus is going to M plus minus n electron, so this is the basically n plus is n plus is absorbing n electrons and forming M. So this is basically E reduction potential. This you have heard in class 11 that you have encountered the series of reduction potentials of different species, right? So this is the reduction potential. Okay, now for the same species I talk about, if you think that M to Mn plus, okay, is this, and the reverse is Mn plus to M. So for same species, the oxidation potential, electrode potential, and the reduction potential are numerically same but opposite in sign. Okay, let's say if I give you an example, it will be very clear. Let's say if I give you an example, it will be more clear. Let's say E0, E reduction potential, okay, E reduction potential of copper plus 2 to copper. Okay, this reaction, reduction potential of copper plus 2 to copper is basically nothing but 0.34 electron volt, right? 0.34, sorry, volt, 0.34 volt, not electron volt, volt. Okay, this is copper plus 2 to copper reduction potential. Okay, so what is the oxidation potential then? So E ox copper plus 2 to copper is minus 0.34 volt, right? This is the oxidation potential, right? That means for E oxidation potential and reduction potential are basically same, but magnitude is same, but the representation is one, it will be if positive, then other one is a negative. Okay, then if I say that for a particular cell, for a cell, if I think about for a cell, then E of cell, if I say, that is the E of, that means E of in the cathode, E of cathode plus E in the anode, right? The potential, the total potential of a cell, if I talk about the total potential. So one reaction will take place in the cathode and another reaction will take place in the anode, right? So E cell is nothing but what? The cathode plus anode, right? Okay. Now, generally, in a chemical, in your any cell, okay, generally in a chemical cell, your anode, okay, your anode is put in the left and the cathode is put in the right. Okay, this is a convention. Okay, let's see if you have this cell. Okay, okay, if you have this cell, okay, and in this case, your anode is put in the left. This is your anode. Okay, AN is your anode and this is your cathode. Okay, the anode is put into the left and the cathode is put into the right. That's why sometimes it is written as ER plus EL also. Okay, so don't think about it. This is something you have written ER plus EL, but better you should go in this way, E cathode plus E anode. Okay, acha. So in case of Daniell cell, if I think about, so in this case, let's say, in this case, acha, E of reduction potential of zinc plus 2 to zinc is value, okay, is 0.76, is 0.76. Okay, acha. Now, what will be the value of E cell here? What will be the value? The E of cathode, E of cathode is, E of cathode is the reduction potential of copper to copper plus 2 copper, that is E of copper plus 2 copper plus E of, if I think about, is what? Reduction potential E of the anode, E of the anode. Okay, E of the anode means here zinc plus 2 to zinc, right? So what is the value? Here is 0.34 and is minus 0.76, because here what is happening? Here is basically the oxidation is happening. So it will be 0.76 to the minus 0.76, right? Okay. Minus, I'm sorry. No, something is wrong. Okay, this will be, oh, sorry. This is plus. Okay, this will be plus. Okay, 0.34 and plus 0.76. And it will be is equal to 1.10 volt. Okay, one problem is that the reduction potential of Zn plus 2 zinc is minus 0.76. Okay, so when you put here, it will be the oxidation, right? So this is basically the E of copper plus 2 copper, okay, minus of E of Zn plus 2. Okay, so this is basically your, if you put it here, okay, this is the opposite. So minus, minus, it will be plus, okay, plus So minus of 0.76. So this is basically your okay, this is zinc Zn plus 2. This is Zn plus 2. If I reverse this, this is Zn plus 2 Zn. Okay, now it's fine. Okay, so this is the E copper plus 2 copper. It will go to Zn plus 2. So if I reverse this, it will be copper plus 2 copper, because it's a reduction is going on, and here the oxidation is going on, right? So it will be reverse will be the reduction. So minus Zn plus 2 Zn, and just I put that value. Okay, this minus 0.76 and 0.34, so it will be plus 1.10 electron volt. So indeed, if you combine this zinc and copper in a particular Daniell cell, what you will find out? You will find out that okay, indeed that cell generates the potential value. Okay, the potential value, and which is the 1.10 electron volt. Now, if I say that okay, then when first you will ask, okay, one thing you will ask, where I got this value, this minus 0.76 and then 0.34 volts, where I got this values. Okay, so let's say I'm rubbing this part. Okay, let's say you did some reaction. Okay, you did some reaction, and in that reaction, in that you did one chemical process where you take a beaker. Okay, and here you, let's say, took a Zn plus 2 solution. Okay, Zn plus 2 solution. Okay, now in the Zn plus 2 solution, and you dipped an electrode of zinc here. This is a zinc electrode. Okay, so what will happen here? In this case, you will have a zinc 2 Zn plus 2. This equilibrium you will establish. Okay, so in all the cases, you can establish all the elements. If you take one solution and one electrode, you can establish this relation. Okay, you can establish this reaction. Now, if I, let's say, here give another electrode, okay, if I give here another electrode, okay, let's say this electrode is A electrode, somehow A. Okay, so if I combine both, so it will be E of cell, which is equal to E of cathode plus E of anode, right? It will happen. Okay, so zinc, since the zinc is going to Zn plus 2, then zinc will be at anode and the other one will be at cathode. So this will be La, and this is for zinc. Okay, zinc. Okay, now think very clearly. This is your experimental. Okay, and you are getting an output. You are getting an output measurement. You are getting E cell. Somehow you are giving. So what I have taken? I have taken a system where I took one A and zinc with the zinc solution. Okay, and I am calculating the E cell with experimentally. Now the output, what it will give? Let's say it gives some output. Okay. Now I'm assuming, okay, for a standard I'm assuming, okay, that this E is basically 0. If I think about, okay, this value is basically 0. If I think about, then your E cell will be equal to EA, right? Your E cell will be now equal to EA if I assume this 0. Now this electrode which I am talking about A, okay, is nothing but our hydrogen platinum electrode, which has E value 0. The electrode potential is 0, and this is known as the standard. Now this value of the zinc which we get here, what we get here, if it is equal to 0, then Zn plus 2, Zn value what we get is minus 0.76 volt, and that is basically nothing but the electrode potential of the zinc electrode. Okay, now if this reaction were carried out in where, if this reaction is carried out in number 1 molar concentration, 1 molar concentration, number 1. Number 2, if this is carried out at 298 Kelvin, number 2. And number 3, 1 bar pressure. So these are the conditions. If this reaction is process is carried out in 1 molar concentration, 298 Kelvin temperature and 1 bar pressure, then this E value is this reduction potential of the zinc Zn plus 2 is known as the standard reduction potential. Standard reduction potential. And we define this as a E0. Okay, when I say E0, that means it is the standard reduction potential value, and this reduction potential is value reduction is calculated in 1 molar concentration, 298 Kelvin temperature and 1 bar pressure. Okay, by taking the reference electrode, which is hydrogen platinum electrode, which has E0 E value is 0. Why we are taking this 0? Because this is a standard. Okay. Now, those, if I take E is equal to 0 here, so some of the elements here, if you see the reduction potential chart, some of that here, the reduction, this was the rate. Okay. This rate will be, let's say, positive. Some this will be positive, and this rate will be negative. Okay. Now, if I compare in both cases, if this higher value of the reduction potential, that means that particular element will have a higher tendency to get reduced. I'm telling again, the higher value of the reduction, more positive value of the reduction potential indicates that particular element will have a higher tendency to get reduced. That means if that element has higher tendency to get reduced, that can behave as a good oxidizing agent. And reversely, if your reduction potential value is very low, so that element will have a lesser chance to get reduced. That means it will have a higher chance to get oxidized. That means it will behave as a good reducing agent. So if your E0 E is very high, E reduction potential is very high, okay, then the element will behave as a good oxidizing agent, and if your reduction potential is very low, then it will behave as a good reducing agent. Similar, but the opposite will apply. Opposite concept will apply for the for if you apply for the oxidation potentials. Okay, so basically, so reduction potential and oxidation potential are basically reversed, but they are magnitudically both are same. Okay, so this is the concept for the galvanic cell. You need to understand the standard electrode potential, the cell potential, and how the reduction potential is coming, and the reduction potential series, and how the standard electrode potential is calculated. So these things you need to understand. Okay, and just go read this lecture and go read the book. Okay, and do some problems. Okay, in this, and understand this concept very clearly. Okay, chalo, till then, bye.